Hello, I'm Álvaro Calafell and I'm going to present the first part of 4 videos about the harmonic problem solutions. These videos are the last sessions about harmonics. In these sessions, first, a guide to choose the best solution will be introduced. Then, the different proposed solutions will be developed. These solutions are for electrical installations polluted with harmonics due to the presence of nonlinear loads and should follow the following schedule. First, we must take measurements of currents consumed by nonlinear loads and voltages at the point of common coupling to characterize the harmonic distortions. These results can also be derived from the resolution of the harmonic problems as presented in the 9th, 10th, and 11th video. The results obtained may allow to identify the harmonic perturbations and the origin of the harmonic problem, and to propose the corresponding solutions. The location of these solutions in the loads, secondary, and main distribution panels must also be decided on the basis of the analyzed harmonic problem. Broadly speaking, the solutions can be divided in two types: solutions related to installations and nonlinear loads, and solutions related to reactive power compensation equipment. We will decide one of them depending on the harmonic problem detected in installation. Regarding the solutions in installation and nonlinear loads, we can separate between the filtering equipment and other particular and more specific solutions such as third harmonic filters, electromagnetic interference filters, and immunized residual current devices. The following table shows the main perturbations, their origin, their possible solutions, and their locations. This table will be useful as a guide for choosing the best harmonic problem solution. Regarding the installations and nonlinear load solutions, we have the following issues and solutions. For the overload of the neutral conductor, due to the third harmonic circulation in the neutral conductor current, the solution will be a third harmonic blocking filter placed at the neutral conductor. Another perturbation would be the interferences in the electronic equipment due to the high frequency conducted. The solutions are high-frequency filters located at the load panel. Next is the residual current device strip due to the high-frequency current leakage. Solutions are immunized residual current devices and harmonic filtering equipment. The former located at the main distribution panels, and the latter located in the distribution panels. The last perturbation in installations and nonlinear load solutions is the heating due to the overload of equipment and facilities. This is due to the existence of harmonics of different ranges, and the solution is harmonic filtering located at the secondary and load distribution panels. Regarding compensation equipment solutions, the main issue is the capacitor bank overload, electronic control problems, and vibrations due to the resonances between the capacitor banks and the reactances of the transformers or grid. The solutions are capacitor bank protections and resonance mitigation equipment located at the main distribution panel. So, given an electrical installation, we must analyze and identify one of the presented concerns and apply the solution suggested in the table. In the next videos, we will develop in detail the solutions presented in this video. This is a continuation of the previous video about harmonic problem solutions. In the first video, I introduced a guide to choose the best solution for the harmonic problems, and in the present video, I will present the solutions to solve particular problems in electrical installations. In the previous part, the harmonic problem solutions were divided in those applied to the electrical installations and nonlinear loads and those applied to the compensation equipment. I will explain some of the installation and nonlinear load solutions. In particular, I will present the third harmonic blocking filters, the high-frequency filters, and the immunized residual current devices. As presented in the 14th video, the neutral conductor current is not zero in presence of balanced single-phase nonlinear loads, because the harmonic multiple of 3 flow through this conductor with a root mean square value 3 times the root mean square value of the phase currents. This can produce the overload and heating of the neutral conductor current. So in general, the cross-section of this conductor must be equal or greater than the cross-section of the phase current when the electrical installation supplies single-phase nonlinear loads. However, the option of installing a third harmonic blocking filter in installation exists when the cross-section of the neutral conductor current is not enough to drain this harmonic. The third harmonic blocking filter presents a high value of the impedance at the harmonic to be eliminated. Therefore, this harmonic doesn't flow through the neutral conductor. In order to select this filter, the nominal voltage, the frequency, and the current are required. High-frequency perturbations produced by power electronics can pollute with high-order harmonic currents the electrical installations. EMI filters can be connected in order to avoid this issue. These devices filter the harmonic currents, avoiding their penetration in the electrical installations. The residual current device measures the current flowing through all the active conductors of the installation. It detects any residual current due to an insulation fault, and it opens the switch to eliminate this residual current. Power electronics produce high-frequency harmonic currents, which can flow through the parasitic capacitors of the device towards ground as the residual currents. These high-frequency currents may trip the residual current switch when they are measured. In this condition, the residual current devices open the electrical installation when power electronics are connected, but there is no fault in this installation. To avoid this problem, immunized residual current devices can be installed which have a high-frequency filter to block the high-frequency currents measured by the device, avoiding the opening of the switch. The main characteristics of the immunized residual current devices are the voltage, the rated current, the sensitivity of the trip current, the delay of the switch trip, and the class.